quantum physicists just found evidence of negative time. Scientists have long known that light can sometimes appear to exit a material before entering it, an effect dismissed as an illusion caused by how waves are distorted by matter. Now, researchers at the University of Toronto, innovative quantum experiments, say they've demonstrated that negative time is not just a theoretical idea, it exists in a tangible physical sense, deserving closer scrutiny. The findings, yet to be published in a peer-reviewed journal, have attracted both global attention and skepticism. The researchers emphasize that these perplexing results highlight a peculiar quirk of quantum mechanics rather than a radical shift in our understanding of time. This is tough stuff, even for us to talk about with other physicists. We get misunderstood all the time, said Ephraim Steinberg, a University of Toronto professor specializing in experimental quantum physics. While the term negative time might sound like a concept lifted from science fiction, Steinberg defends its use, hoping it will spark deeper discussions about the mysteries of quantum physics. Laser experiments. Years ago, the team began exploring interactions between light and matter. When light particles or photons pass through atoms, some are absorbed by the atoms and later emitted. This interaction changes the atoms, temporarily putting them in a higher energy or excited state before they return to normal. In research led by Daniela Angelo, the team set out to measure how long these atoms stayed in their excited state. The time turned out to be negative, Steinberg explained, meaning a duration less than 0. To visualize this concept, imagine cars entering a tunnel. Before the experiment, physicists recognized that while the average entry time for 1,000 cars might be, for example, noon, the first cars could exit a little sooner, let's say 11:59 a.m. This result was previously dismissed as meaningless. What Angulo and colleagues are demonstrated was akin to measuring carbon monoxide levels in the tunnel after the first few cars emerged and finding that the readings had a minus sign in front of them. Relativity intact. The experiments, conducted in a cluttered basement laboratory bristling with wires and aluminum-wrapped devices, took over 2 years to optimize. The lasers used had to be carefully calibrated to avoid destroying the results. Still, Steinberg and Angulo are quick to clarify. No one is claiming time travel is a possibility. We don't want to say anything traveling backwards in time, Steinberg said. That's a misinterpretation. The explanation lies in quantum mechanics, where particles like photons behave in fuzzy probabilistic ways rather than following strict rules. Instead of adhering to fixed timeline for absorption and re-emission, these interactions occur across a spectrum of possible durations, some of which defy everyday intuition. Critically, the researchers say this does not violate Einstein's theory of special relativity, which dictates that nothing can travel faster than light. These photons carried no information, sidestepped any cosmic speed limits. A decisive discovery. The concept of negative time has drawn both fascination and skepticism, particularly from prominent voices in the scientific community. German theoretical physicist Sabine Hossenfelder, for one, criticized the work in the YouTube video viewed over by 250,000 people, noting the negative time in this experiment has nothing to do with the passage of time. It's just a way to describe how photons travel through medium and how their phases shift. Angulo and Steinberg pushed back, arguing that their research addresses crucial gaps in understanding why light does not always travel at a constant speed. Steinberg acknowledged the controversy surrounding their paper's provocative headline, but pointed out that no serious scientist has challenged the experimental results. We've made our choice about what we think is a fruitful way to describe the results, he said, adding that while practical applications remain elusive, the findings open new avenues for exploring quantum phenomena. I'll be honest, I don't currently have a path from what we've been looking at towards applications, he admitted. We're going to keep thinking about it, but I don't want to get people's hopes up. This is from Agency France Press by Ben Simon and Isam Ahmed on Science Alert. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.